Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Sodium thiophenoxide, PhSna, is a sulfur nucleophile. The sulfur anion, PHS, acts as a nucleophile in an SN2 reaction with methyl bromide, CH3Br, which is a primary alkyl halide and an excellent substrate for SN2 substitution. Moving on to the next step. Identify the nucleophile and electrophile. PhSna dissociates to give PHS, thiophenoxide anion, as the nucleophile and Na as the spectator ion. CH3Br is the electrophile. Moving on to the next step. Reaction mechanism. The sulfur atom of PHS attacks the electrophilic carbon of CH3Br in an SN2 fashion, displacing bromide ion, Br. This forms PHSCH3, methylphenyl sulfide, also called thionisole, and NaBr as a byproduct. And for the final step, evaluate options. A. Benzene, incorrect, no reduction or elimination is occurring under these conditions. B. Bromobenzene, incorrect, no halogenation of the ring occurs here. C. PHSCH3, thionisole, correct, direct SN2 alkylation of the thiophenoxide by methyl bromide. D. Benzene, incorrect, same reasoning as A. The solvent H2O, diethyl ether, is a non-protic solvent that favors SN2 reactions and does not interfere with the nucleophile. Therefore, the correct answer is C. Therefore, the correct answer is option C.